Hello guys and welcome to another tutorial. In this case we will be learning how to create an amazing particle effect. It is actually very simple and thank God we can do these things in Houdini. Amazing. So stay tuned and watch the full tutorial. Guys, do you want to join a really nice server? We have tons of different channels. We have effects, modeling, loop dev, compositing. We will have resources for every type of discipline. I also have a Patreon page where you can support me. I have every single file, I have polls, I have even some tools, guidance. So if you are interested, you may have a look. Thank you. Okay guys, so let's create this beautiful effect. To begin with, there are a couple of things we need to understand, and it goes as follows. We need to create the source or the sources to begin with. Everything is going to be piped into this Vellum Solver. Then we're going to be saving the points and then just instancing them with geometry. So I wanted to start by creating a sphere, which is then clipped at the bottom, like so. You can see. Then I'm just translating it a little bit upwards in position. This will allow the particles not to pop everywhere in the simulation. And I'm going to be doing two things. First of all, let's create some grains with the Vellum constraint grain. Just adjust radius to avoid overlap. That way we won't explode at the beginning of the simulation. And we create from volume. On the other side, we're going to create a couple of points with a simple mask that looks something like this. This will help to create some attributes while we work in the simulation. We want to transfer this over here to the points and consequentially just create another noise. Why I'm doing it like this? Because I'm also creating a velocity after all. So that's why I'm just transferring. I could have done it here, but I prefer to do it here. So now that I have a mask number 2, let me show you mask number 2. This will be the points or places where the geometry will start to just move upwards in the simulation. This will be an attribute noise, which is called activate. And what we're going to be seeing is the activation points. So not every point is going to be activated at the same time during the simulation. Then a couple of, just a color, some orient. This is very important. So the initial particles have a different orientation when they begin. So keep in mind to have this. Also, this is not necessary. This was for another test, but I just wanted to try it something else. You can have it turned off. And I'm deleting pretty much everything. I'm just creating a random selection. Yeah, that's pretty much it. And I don't think we're doing we're not doing anything with this, but this could have been used to create some sort of selection, right? Like let's say half of the particles you want to make something during the simulation. So we have the main source, which is going to be plugged into the solver. We have some velocities. We're going to be doing something inside the solver. We have the constraints, which is just nothing, but just plug it in. Otherwise, it might cause errors. And over here, which is after the mask, what we're going to be doing is to have a little bit of velocity. As you can see here, it's very, very small. Here's very a lot. It's just a little bit, so it's not so uniform. We're also going to be creating this vex function, which we're going to be normalizing the velocity. We're going to be adding the normalize of the negative position. Basically, the negative position is everything is going to go inwards, and we're going to be multiplying it by this array. That way, we are only going to have vectors going inwards, but not up or down. So that plus the other creates like this sort of inwards with a little bit of noise. That's how it is. And then if we rasterize everything, this is how it looks. I'm just rasterizing the velocity because it's all I need. This is going to be for the advection. As for the curve, before I leave this just because I want you to see. I used to have a pop advect by curves. I didn't quite like it. it's not that great, so you should probably do your own here. But I just wanted to leave you an example of how this was done. Just align with the example and align. But we could totally just get rid of this like so, and the same goes for this one. Finally, the last source we're going to be creating is a pyro source. Is with a pyro shape. It's just a sphere with a noise on temperature and density. The way to do it is with a nice offset, like so, and then with noise here, volume noise fog. What you can do is to just multiply a ramp. This has to be called the same density. There we go, and you can just have fun with this, and it's exactly the same. One is going to be called density, and the other can be called temperature. You can do the same thing over here, temperature. Just change the offset, and then if you merge these guys together, boom, you have your own source, which should work just fine here. Density, and that's all I'm doing with this tool, but you can of course get it through my Patreon page. And what I'm doing here is also to work with GPU. I prefer working with GPU for these type of really fast examples. So all I did was voxel set to this, time scale to the half, minimal CPU. The bounding box is just something very small. Sourcing, I want all of this sourcing to be working. I didn't change anything here. The only thing I changed is on the turbulence, and I added 1 to turbulence, nothing else. On advanced, I should have changed this, but it doesn't matter. And I didn't do anything else. Just regular stuff. Press play, and it works real time. With this, what I also did is to save 1 frame to get a bounding box of this. And then I created a BDB, which I'm then activating with the reference to create lattice and then bend the lattice, as you can see here. So this is with the volume deform. If you press volume deform, boom, it just creates it on its own. And over here, I just pyro process everything, and I blasted everything that I didn't need, which is basically just everything but the density or the velocity. So what I am doing with this is just I'm bending it, and then I'm just deleting everything but the velocity. So I saved this into disk because this step is very slow, right? So how does it look? Well, if I just capture everything here and I look at the volume trail, it basically looks something like that. As you can see, super nice. So it's basically the upward motion twisted so we can have like this tornado kind of velocity effect. And that's all there is. That's pretty much all there is for the source step. Moving downwards, if we go to the Vellum Solver, which is the most critical part, we have this, and we have, well, nothing else, just the Vellum Solver. So I'm going to set a quick mark with Ctrl+1, hop in, and go back. It's Ctrl+2. So with Ctrl+1, I'm going to just leave this so we can see. What the first thing we want to do is just to activate, to transfer this activate out the out B2. The out B2 is basically this activate noise. Why I'm doing a subsolver? Because I want to transfer, in fact, in this case, to copy the activate value. And if the activate value is bigger than 0.8, it's going to be on the group in. So I'm just setting a group. That's all I'm doing here. Going on, we're going to be creating, based on the mask number 2, a force, which is going to be adding upwards. That's why only y-axis is going to be multiplying by the force, which I'm just animating here, as you can see. So if I were to press play, nothing is going on. And then we're going to be having this small push right here in this step, where only the pieces which have this mask 2 are going to be affected. And I'm also having this activate value over here. I don't know why I have this activate value. I could totally delete this. Yeah, I could totally delete this activate and nothing would happen. It has to be a test, something I created. So that's about it. And for the next one, it's just a pop at the back volumes, but we are going to be grabbing the in group we created here with the velocity 3. And the velocity 3 is this one, is the tornado kind of effect. So let's hop in and watch how that looks. So as time goes by, more particles are going to be hopping into the group. So not all of them are going to be moved at the beginning. So we're going to be creating that kind of shape. It's just force 2.1, and I'm not treating it as a wing. That's all I'm doing here, nothing else. And I have another force, which is this one, which is the inward force. And the inward force looks something like this. For all of the particles, because I don't have any group, for all of the particles, they are all going to be moving inwards. Now, if we apply everything together, this is the end result. As you can see, all the particles are moving inwards. Some of them are going to be activated at the same time, and then this wheel is going to take effect, and it's just going to work. It's just going to do exactly what I want it to do, which is a spiral in the middle, some particle floating, and an inward velocity going inwards. That's about it. That's all I'm doing. Then this is the simulation. I want to adjust the P scale. As you can see, this is how it will be looking without anything, with just a minor tweak on the P scale, multiplying it by this value and creating a ramp, as you can see here. And I'm creating is this kind of interesting shape on everything. Then I'm deleting pretty much nothing. I don't know why I did this, why I'm not doing anything with this, ignore it. And I'm doing a simple noise just to add a little bit more of a shape. And this is where it gets a little bit glitchy. So what I solved is by just copying the P attribute. So you can watch this in real time. It's just a way to move around the simulation without actually having to simulate again, just with a post process. And when I'm shifting this to a place I liked, because I liked this beginning shape, with a simple wrangle, I'm creating some IDs because I need IDs for the vector time. The vector time is a node that you can look up in my YouTube channel. I'm going to leave a link in the description. And what this does is just a way to easily simulate in slow motion. Have a look. So this is what's going on. I'm basically visualizing this in slow motion. Whereas if I go here, it's super fast. I just simulate less frames and have the exact same result. The only thing I need to do is to trail again the velocity to normalize the vectors again. And then I'm just keeping what I need, the velocity, the CD, the P scale, and the orient. I don't need pretty much anything else. This is another node, which I'm going to be explaining. For this node, watch the tutorial because it's a little bit more complex. But for this one, I can show you right now. It's just a way to create a variant integer from 0 to the number you have here. So if it's 4, it's from 0 to 4, and then you can remap it. So what's going on here is just an attribute randomized, as you can see here. It's just a variant and nothing else. Yeah, dimension of 1 is a custom ramp, and then I use an attribute cast, which is casting the attribute into an integer. And this is something I do over the time, so I just wanted to have it into a singular node. Then a new randomize, because I want to add some more values into the shading aspect of it. And saving all the points simulation here. So I don't need to do everything again. I just use 100 frames. So that was about it for the simulation. Finally, for the sub stage, what we wanted to do is just to create a cube where I smooth it out. I edited some places to make it a little bit more sharp. I poly extruded them. I did a bevel where I wanted. And then I have two selections, either one of these or the other, where I smooth it out. Also smooth out here. Then I saved some rest positions in both of them because I'm going to be using this for the shader, for the tree planners. And I'm packing both of them. I'm also matching into the center. They're merging both back geometries, as you can see, into the same merge and transforming them a little bit so it's a little bit larger. And these are the points. And if we use the points, which have the variance attribute, as you can see here, and use it here, it will grab the 0 and the 1 based on the number. So it's going to be interpolating between both of them. If I were to select something like this, boom, now I have another geometry, but I don't want to. And then I'm going to be configuring this. The only thing you need to do in this case is just to go and create a point instancer. Otherwise, your PC will explode when you load this into Solaris with a SOP import. Going into Solaris, what I'm doing here is setting the scene. As you can see, all of the folders I want to have. This is just a geometry. Then I'm grabbing the camera. In this case, the camera is over here. And what I created is just with the letter set. If I select with the geometry and press enter and set, you can change the focal distance over here in sampling. That's the only thing I did here. And then I saved this camera into $job, which is by setting the project into the heap. That's the only thing I did. And I've saved it. So it's full USD. Do this if you're going to having camera motion blur. The same for the particles. You have the particles here, which is very nice to have, but look at this, it's a little bit slow because it's injecting every single time into USD. It's transforming everything. Well, the only thing I did is just to set this into scene, CFG and Zim. And basically this is the nomenclature I'm using here. So when we have all of these merged together, it's going to be looking something like this. And look at how fast it changes when you have it as an actual USD, whereas if you are importing it. So it makes quite a difference. And saving this is not expensive at all. You just save the, it's actually saving the points and the geometry. The geometry is going to be saved as the prototype, one frame, and the points, which are on the instances, is the only thing you are going to be saving. So this is the way to go. Save the USD whenever you can. If you merge everything, separating the layers, you will have here everything. You save the camera, the simulation, and all the structure, and then you just save a single frame of this, because one single frame is going to be referencing the camera and the simulation animation. And that's all it. This is the scene you want. Then it's just a simple grid, which has a curvature, as you can see here. It's just I'm editing this, creating a poly extrude, a bevel, and also divide, and a normal. That's it. Then just creating some lights. This is with Arnold, but you can do it with Karma. Don't worry. It's just one HDRI over here. Let's go to Arnold 50. I don't really know why this is red. Interesting. Maybe it's because... Okay, there we go. Strange. We'll save this. So it's just a lat long image of a dome light, and with Arnold I have more samples, and the contribution set to 0, and an AOB light group set to dome. This is so you can separate the lights. And I think I'm doing is to create a ring light over here. This ring light is just to play a little bit with the lighting. I don't really know why this is here, but I guess we can ignore it. Yeah, we totally can. There we go. Let's just ignore this. I don't remember what I did to make it appear like in the middle. Don't you worry. It's the light is somewhere over here. So I guess this is just a bug. Yeah, it's a bug. Don't worry. And the material library. This is a very interesting part. So I'm creating a material. Let's go to the material linker. What I'm doing here on the material aspect and the geometry render settings. In this case, this is for Arnold. What you need to do with Karma is just to go into the geometry dicing and set this to the value you want. One is one of lines per pixel. Let's just pause this for the timing. This is one per pixel. And in Arnold, you got to just copy this setup. Basically, you have 7 iterations and an adaptive edge length. I didn't put any adaptive error. It doesn't matter. With a height of 1 and 0 value of 0.5 because I'm using displacements. So let's remove this grid and press Shift P. I'm going to be changing this. No, this is okay. There we go. This is what we're aiming for. Let's just go into some of this. Oh, let's go again back here. So I don't know how this is going to be listening. I'm going to check. Okay, so my camera might be looking a bit odd, but doesn't matter. So what's going on here inside the materials? So I have this setup, which might look a little bit interesting. So let's go one step at a time. First of all, what's going on here? I'm just grabbing the display color, the RGBA over here. There we go. So this is me just grabbing the color. It's just an image texture, as you can see. But as I don't have any UVs, I'm sending it into a triplanar. And the triplanar is set to pref. The pref basically means the rest position. So we can see something going on here. Then there is a slight color correction where I'm just reducing the saturation to the minimum. And then I'm remembering that I have colors which I created beforehand. I just want to have the blue one, but it's not interpreting the blue one. Yeah, so if you go here into the float, it should work. This is the blue one. It's just remember this is supposed to be set to 1 and not to 2. If you cannot see this, you can go Asset and Asset Definition Tool, Show Menu Always. I'm just creating some remaps and I'm coloring this. This is the base color I'm going to be using. And this is based on the random. This is based on the display color, which is the actual CD. And what I'm doing here is to creating some values of yellow. So if we merge the base color and the texture with the yellow one, I'm going to have this variation of tones. With a color correction, we're going to be correcting it a little bit. And we're going to be setting this to the surface color and to the surface radius. But on the surface radius, I want it to be a little bit more on the dark side with less saturation. And the subsurface is going to be set to 0.06, random walk 2, subsurface to 1. Nothing else. Nothing else. As for the roughness, the only thing I did is just to grab the roughness map and just set it up over here. This should be set to, I don't know why they got reset, but it should be set to utility raw. Same as this one, it should be set to utility raw. And the diffuse, that's a good question. What did I use? sRGB ACs. Yeah, I left it as it is. Yeah, sRGB ACs. I just didn't do anything. I just wanted the default to take place. The normals, exactly the same. The rest position, all of these are linked together, as you can see. With Control, Shift, Alt, and drag, that's how you create that. But in this case, I just copied the first value. And all of these things considered, the only thing is to keep the displacement set to displacement and the surface set to the surface, and voila. Now it's converting this normal to raw. That's the only thing that's happening. Otherwise, you might be getting something different on the display. So while this loads, the floor is just a simple roughness. And well, this is, remember, set to the prototypes. This is very important. And this is basically just ground the prototype for this material and the floor for the grid. It is important for this to be the prototypes because we're shading only the objects and not the points. Going downwards, in this case, what I did is to just hide, because I have the grid, right? But I hide it with the camera ray visibility. See, I selected because I want to have some bounce light from the ground. Then I'm setting these Arnold render settings using the shot cam, which is here. Oh, and also the shot cam was saved into the scene /_cam. I'm rendering this with GPU right now, which is going to be way faster. I think I'm going to crash. Maybe, yeah, I crashed. So I'm going to continue this with CPU, otherwise I might crash. So ray depth, I changed this to 2 and 2 just for the ground bounce lights and sampling. Well, this is supposed to go to GPU, so with GPU it's way faster. But 20 and 30, I know it's a lot, but I also have a lot of the focus with the camera. The SSS to 4, adaptive threshold to 0.02. Over here, I didn't do anything here because I don't want to use normal position, whatever, for the comp. The only thing I did was to create these render bars after the fact, which what I'm doing is just grabbing the source name, which is RGBA DOM, which is basically the code of what I want to separate by the light group, which I created here. I'm going to just post this. The same thing is going to happen for the ring light. And as you can see, the render product is going to be exactly the same one. It's going to be called the same because I also have a render product over here. Render products and render products. So I want to override this with a new one. What does it mean? Basically, it means that I'm going to be saying the same thing here. And the only thing that I want to create is this rim and dome, which they are already created here, but this will basically just put it into place when we create. It will make them appear, basically. See? Now if I select the wrong over here, if I go here, I don't have the dome and the rim, but if I go into the product, it's already ingested over here. They are ingested. And the final render settings, the only thing that I did is to grab the other products and again use these render products. Everything has to go over one render product, otherwise we might get errors. And I just disabled everything and just wanted to override the resolution. And over here, this is, you can do the same with a simple render wrap and just set the frame rate over here, set this to Arnold and render to disk. I just send it to the farm with Prism pipeline. And that's how you create it. And how does it look? This is the dome and this is the ring. Finally, as for the comp, this is extremely simple. I have this image, which I'm then shuffling the light groups, A and B. I'm unpremulting, so I can do some slight color corrections over here. You can see. I'm just adding gamma, saturation, whatever. Over here is exactly the same thing. Then premulting this, so it goes back into normal. The alpha, as you can see here, is adding the alpha again, but I just want to override it with the one time. Otherwise, I'm going to have two because I'm using plus. And this is with, I believe, Alt-H. Yeah, with Alt-H, you just hide it. And now I have the alpha over here. Then I'm merging it with a constant of white, which is, I'm just exposing it so it's a little bit bigger. Otherwise, the background is not that great. Then I'm creating a luminance. So this is the alpha. And what I'm doing is to glow into different sizes. I'm merging everything so I can create an exponential glow. I'm multiplying this by a smaller value and merging it back again into here. So we can have this kind of glowy effect. Then I'm using a small color correction, which, yeah, it has some very small values over here. Nothing great. I'm transforming everything, all the red values a little bit bigger. We can have a small chromatic aberration. And I'm distorting the lenses inwards and then just transforming everything outwards. You can see, boom, 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 boom. And then I'm just cropping the accent and I'm just creating a small gradient, as you can see here, and adding a little bit of grain so it's not so CGI. Well, I should have removed the original grain, but I didn't. And I just saved everything into output RGB with FPS 24 and upper ProRes, and everything is using the Ocho color space. Thanks for watching the video. So if you have any comments, any requests, whatever, please leave a comment down below, leave a like, subscribe, and everything else. See you, man.